Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope you all are doing very good. So students, in this video we are going to learn the magnetic force acting on moving charge particle. We will learn for positive charge particle and we will also learn how to apply the concept for negative charge particle. After that we will learn some important points, some important concepts that can be explained by the concept of a force. After that we will solve a NEET and JEE questions also, that is very important. Okay, so let's go through the video. So under the topic magnetic force on moving charge particle, see here, when a charge particle Q moves with velocity v in a uniform magnetic field B, then magnetic force experienced by the particle is given by. Okay, so here what is there, I have taken one charge particle Q that is at the origin. Okay, after that let's take here, this is the some plane. Which plane is there? I have taken here the ZX plane. Now, and let's take here the charge particle is having the velocity in this direction. Now, this is the velocity. Let's take the velocity is v, is it? And after that, if we talk about here the magnetic field, so let's take this is the magnetic field, for example. Now, and this magnetic field is B. Now, in which plane I have taken? I have taken in a ZX plane. Okay, to keep the thing simple. Now, let's take angle between velocity and magnetic field is theta. Okay, so in this situation, the force experienced by the charge particle, magnetic, that means Fm, is given by Q times V cross B. And here I am writing for the positive charge particle here. Okay, and how to get the direction of the force? Direction of the force can be get by right hand thumb rule also and Fleming's left hand rule also. Okay, so if we see the this one here, right hand thumb rule. So here you can see very well, it is written what is given. See, when we curl the fingers of a right hand from first vector to second vector through a smaller angle, then thumb indicates the direction of a magnetic force. Okay, so what is telling that here? Here we have velocity and magnetic field. So let's take, this is the velocity, this is the magnetic field. We have to curl the fingers from first vector to the second vector through the smaller angle. This side angle theta, opposite side 360 minus theta, so we have to curl like this. Okay, then what will happen that here? This force. Now what is this? This is the force along which direction? Y direction. Velocity ZX plane, magnetic field ZX plane, and this is the force which direction? Along Y direction. Okay, so what will happen that here? This will be the force here. Okay, magnetic force. So here what is the formula? F equal to Q V cross P. After that, if I write here the magnitude, so what is the magnitude? See, with very basic I am writing here, mod of Fm is given by Q into mod of V cross B. And what is mod of V cross B, students? VB sin theta. That means we can write here Q into VB sin theta. Here, this is the formula. What is the formula? QVB sin theta. Okay, this is for the positive charge particle. If we talk about here, see, for a negatively charged particle, which charge particle? Minus Q. So in this situation, remember that here, students, say this magnetic force formula will be given by minus QV cross B. What will come here? Minus QV cross B. Or can I write here? Q into B cross B. Okay, because when minus sign will be multiplied, V cross B will become B cross V. Okay, so this thing we have to remember that here. Is it? Just let me draw here the box. Now, this is the formula is there. Okay, see here. Can you see here? Now, this is the formula for the negative charge particle, and here I have to put here this minus sign not there now, because V cross B I have written B cross V. Is it? And here if I write here, just try to understand, this is the plane. Is it? And again I will draw here the some, let's take here, this is the velocity now, and let's take here, this is the magnetic field, making how much angle? Theta angle. Is it? And which charge particle is there? Minus Q charge particle is there. Okay, then what will happen that here? Here minus sign is there. So if in case this force is acting along Y direction, so this force will act along negative Y direction. Is it? I will write here, see this one here. Which direction? Negative Y direction. Remember that here. And one very basic thing is that as we are learning the cross product, I have told you this is V, this is B. Force is what? Force is perpendicular to both V also and both B also. Okay, so perpendicular means what will happen that here? See, this is the 90 degree. What is this angle? This angle is 90 degree. Okay, and remember that here also this angle, na? See, I am writing here. See, this angle is 90 degree. How much angle? 90. And if we talk about here one more angle, see this angle. This angle is also, what is that? This angle is also 90 degree, like this, see. Okay, here also I can write here angles 90. Now, so see here, how am I writing here the 90 degree angle? Is it like this? Now, this all are 90 degree. So, if I tell angle between FM and V how much? 90 degree. Angle between FM and B how much? That is also 90 degree. Here also just reverse direction, FM and V 90 degree, FM and B also 90 degree. Okay, remember that here. Kindly see, very well. Very basic things we are learning here. Okay, and here also if you write the magnitude, magnitude will be same, Q will be sin theta, not a problem. Okay. Now students, after that here, after learning the right hand thumb rule, now one more rule is there, Fleming's left hand rule. And remember that here, this is applicable for the positively charged particle, for positive charged particle. See here, when we stretch forefinger, central finger and thumb of right hand or left hand, see here, instead of right, what will be there? This will be left hand. No? Left hand. Left hand mutually perpendicular in such a way that forefinger points along a magnetic field B, central finger points along velocity V, then thumb points along the direction of a magnetic force. So here what I am telling you here, now you can see my finger, this is the thumb, this is the forefinger, and here this one, this overall you can consider this now because my finger is like this, this I am taking central finger. So forefinger, thumb, forefinger, central finger. So this is the left hand. So if this is along the magnetic field, forefinger, central finger is along the velocity, then this thumb will indicate the direction of the magnetic force for positive charge particle. If in case the charge particle is negative, then the direction of force will reverse. That means instead of force is going upward, you have to take the force downward. Clear? Again I am telling, forefinger, magnetic field, central finger, velocity and force will indicated by the thumb. For positive charge particle, upward. For negative charge particle, downward. Remember that here. Okay. So kindly see very well and remember this definition also. Okay. Is it clear? Good. Now students, after that we will go for the next one here. See the conditions of a zero magnetic force. Okay. So see what is the force formula. The force formula is that I am just writing here the magnitude Q into QVB sin theta. Is it? This is the force. QVB sin theta, this is the force. Okay. So in which situations the force will be 0? Remember that here. First one, if Q equal to 0. Q equal to 0 means what? The particle is neutral. Now the moving particle is what? Moving particle is neutral. Like a neutron. Okay. Second thing we can write here, V equal to 0. That means here I can tell charge particle at rest. What I am writing here, the charge particle is at rest. Now then also magnetic force will be 0. Okay. Next one, if I talk about here B equal to 0. That means charge particle is moving but magnetic field is not there. Okay. So no magnetic field. That time also magnetic force will anyhow will not be possible. Now one more thing, sin theta is there. So you know very well here sin theta can be 0. That means theta can be how much here? 0 degree. And here also sin theta can be 0. And theta will be how much here? 180 degree. What is the meaning? Here we can tell charge particle is moving along the direction of the magnetic field. So see, this is the magnetic field and this is the velocity. Is it? So in this situation you can see very well here, theta will be 0 degree, it will not experience any force. We can write in the language form, charge particle is moving along the direction of a magnetic field or parallel to the magnetic field. Here what will happen right here, see, this is the magnetic field and this is the velocity. Is it? So in this situation what we can write here in a language form, the charge particle is moving opposite to the magnetic field or anti-parallel to the magnetic field. Okay. So these conditions we have to remember that we can tell parallel vector and anti-parallel vector. Okay, great. Now students, next one, see condition of a maximum magnetic force. So see here Fm equal to QVB sin theta. Remember that here for maximum magnetic force the sin theta should have the maximum value. Okay. So sin theta maximum value plus 1 theta how much possible? The theta will be 90 degree here. Okay. So in this situation what will happen that here students, we can write here this magnetic force will be how much here? Just QVB. This is the maximum value. Now, maximum magnetic force. Kindly see here, is it? So, these conditions, kindly remember that very well. Okay, great. Now, students, let's talk about here. Now, kinetic energy of charged particle. This is the also very important concept. Kindly see here. So, what we know that here, as I have told you very well, what I have told you, let's go to the back here, is it? So, here we have learned that force along y-axis and velocity in a which plane? Z-axis plane. Angle between force and velocity, how much here? 90 degree. Force and velocity, how much? 90 degree. Whether positive particle, negative particle, 90 degree. Is it? So, this thing we have to use here. Is it? So, what will happen that here? See, as we know that, what we know, see here, this magnetic force is perpendicular to velocity. Or we can tell that velocity means Fm is equal to this, V equal to ds by dt also. So, we can tell here, force is perpendicular to displacement also. Why? Because since V equal to ds by dt. Is it? And you know very well, whenever force and velocity is perpendicular or force and the displacement is perpendicular, that time, what is the work formula? Work is always given by, see here, vector Fm dot displacement here ds. Now, so when perpendicular means what we can write here? See, Fm into ds into cos 90. So here work done will be how much here? Work done will be 0. Work done by magnetic force will be how much here? 0. Okay. So from work energy theorem we can write here, work done by all the forces is equal to change in kinetic energy, Kf minus Ki. Is it? So what is the work done? Work done is 0. So 0 equal to Kf minus Ki, we can write here delta K even. So what this will happen that here, we can see very well here students, this delta K equal to how much coming? 0. That means change in kinetic energy is 0. Or what we can tell that here? We can tell here, that means kinetic energy is constant. So whenever the charged particle will move in a magnetic field, what will be there? This kinetic energy will be what? Constant. Remember that here. So see, as work done by magnetic force is 0, hence kinetic energy of the particle is what? Constant. Remember that. Is it? Good. Now students will talk about here acceleration and magnetic field relation. What is this? Here also again we will go backside somewhat. So see, now if we see from another point of view, like I have told, angle between force and velocity is 90 degree. And you can see also angle between magnetic force and magnetic field is also how much here? 90 degree. Why? Because force along y-axis, but magnetic field in a which plane? Z-axis plane. Is it? So students, as you know very well here also it is going perpendicular. So what we can write here, can you see here? See, Fm is perpendicular to B. And whenever perpendicular, dot product how much here? Their dot product will be 0. Magnetic force dot B equal to 0. Because theta how much? 90 degree perpendicular, and A dot B is AB cos theta. Perpendicular means theta 90 and cos 90 is 0. So dot product will be 0. Is it? So what will happen that here? You know Fm equal to Ma. So M vector A dot B is equal to 0. So hence what we can write here? Remember that here, vector A dot vector B will be how much here? This will be 0. Dot product of both will be 0. And what I have told you the formula, these are just general formula. What is the general formula? I am telling you this one here. In 11th we have learned vector A dot vector B means AB cos theta. If vectors are perpendicular, now then what this will become here? AB cos 90 and it will become here 0. This basic I have just told you. So as they are perpendicular, that's why their dot product is be how much here? 0. Is it? Can you see here? Is it? Great. Now students, after that here, if we talk about here some questions now. So see here, now we are going to solve the question. See the question, JEE 2022 question is there. What is the assertion? See, in a uniform magnetic field, speed and energy remains the same for a moving charged particle. As I have told you, kinetic energy constant. Kinetic energy formula half mv square. That means speed is also constant. Is it? What is the reason they are telling? See, moving charged particle experiences magnetic force perpendicular to its direction of motion. I have told you vector F is perpendicular. See here, vector F is perpendicular to the displacement. Okay, or we can tell vector F is perpendicular to the velocity. Anything is okay. Okay, perpendicular to the velocity. One more thing I can tell you, power delivered by the force. So power is also given by vector F dot vector V, power is 0. Or from here also we can tell work done is 0, or we can tell this kinetic energy is a constant. Now anything, all are interconnected only. Okay. So assertion is also correct, region is also correct, and region is the correct explanation of the assertion. Okay. So correct option is what here? The correct option is here. Option A is the answer. Is it correct? Now students, let's move to the second question. The second question is what? Asked in a NEET 2006 exam. So see, when a charged particle moving with velocity v is subjected to a magnetic field of induction B, the force on it is non-zero. Is it? So what is the force formula? F, no, magnetic force, is equal to QVB into sine theta. They are telling that the force is not 0. Is it? The force is not 0, and they have given the angle condition. That is only possible when sine theta is not 0. Is it? Sine theta is 0 at which angles? 0 degree and 180 degree. Except 0 degree and 180 degree, sine theta will never be 0. Okay. So except 0 degree and 180 degree. So what we can tell here? See here. They are telling it should have the water, the force on it is non-zero. Okay. So see here please. Option D. What is the angle? See here. Angle between, that means angle between what? The angle between Q and angle between V and B. Okay. Angle between V and B, velocity and magnetic field. Okay. Can have any value other than 0 and 180 degree. Okay. Angle between what? V and B. Is it? Great. Now students, after that, let's go to the next question. The question is what? See here. For important for NEET, a charged particle is projected in magnetic field B equal to this one. The acceleration of the particle is found to be this one. The value of x how much? Is it? So what basic I have told you students, as I have told you, this magnetic force is perpendicular to the magnetic field. So what was there? The dot product of vector A dot vector B was how much? 0. Is it? So dot product is 0 means what we can write here? Kindly see here. No? No? Just let me write here. So what will happen that here students? Let me write here. See. So what is the vector A? Vector A, they have given this one here. Xi cap plus 2j cap, and B how much is given here? See here. B is given here. See. 3i cap plus 4j cap into 10 to the power minus 2. Is it? Just take the dot product students. So see here, vector A dot vector B. Just multiply the coefficients of I cap and I cap. Here x and here 3. So it will become here 3x plus 2 and 4. It will become here 8. So 3x plus 8 into 10 to the power minus 2. Is it? This came. But what is this? Actually, this vector A dot vector B should be how much here? 0. Is it? So from here, what we can tell that here, see, 3x plus 8. No? 3x plus 8 will be how much? 0. No? Power anyhow, it will be balanced. Is it? So x what will come here? The value of x should be minus 8 by 3. Okay, can you see here? Is it? So x should come here what? The x should come here, students, minus 8 by 3. Okay, A dot B is 0. Now students, after that we'll talk about here the JEE 2020 question. So see here the basic question. A charged particle carrying a charge of 1 microcoulomb positive is moving with velocity this one. If an external magnetic field of this exists in the region where the particle is moving with the force on the particle, how much is given? F into 10 power minus 7 Newton. The vector F is how much here? Okay. So again, we will use the formula. What is the formula is there? Kindly see here. This formula is magnetic force is given by QV cross B. Is it? QV cross B. After that, what is the value of the Q? 10 to the power minus 6. And you can see with magnetic field 10 to the power minus 3 is there. Is it? After that, we'll just use here the determinant here na, to get the V cross B. So I cap, J cap, K cap. What is the, first we have to write the velocity. So velocity what is given here? See, 2, 3, 4. Magnetic field what is given here? Kindly see 5, 3 minus 6. So 5, 3 minus 6. Is it, students? So I hope so you know very well how to take the determinant. So when you will solve here, students, you will take the determinant and all, it will come minus 0.3 I cap, just have to take the determinant, plus 0.32 J cap minus 0.09 K cap into 10 to the power minus 7 Newton. Just have to do the determinant. So which option will be correct here? The correct option here, option A will be the answer. Remember that. Yeah, this only calculations parts are there. Okay, great. Now students, let's see here this question, very basic question. The question is what? See, a very long straight wire carries a current I. At the instant when a charge plus Q at point P has velocity V as shown, the force on the charge is how much here? Okay. So first remember that here the charge particle is positive and magnetic force is given by what? QV cross B. Is it? This is here. No? So see here. Now first we should know very well the direction of the magnetic field. So see, right hand palm rule now. All the fingers along the current, palm towards the point, then thumb will indicate the direction of the magnetic field. So see here, what is happening? My thumb is going inside. That means here at this point, magnetic field is inside. Is it? So you can see very well here. Now what is this? The velocity is along x direction. Now magnetic field is along which direction? I can write here inside. That means negative z direction, inside of the board. According to right hand thumb rule, or you can use Fleming's left hand rule also, because positive charge is there now. So see here, curl your finger from first vector to the second vector through the smaller angle. Is it? So what is happening that here? See here students, just let me see. This is the velocity. Is it? This is the magnetic field inside. So curl V to B, V cross B. Then force is going in which direction? The force is going in upward direction, like this. Is it? So what we can tell here, the force along which direction? The force in this direction. Is it? This is the magnetic force direction here. Okay, or you can use Fleming's left hand rule also. Is it? See here, magnetic field inside, velocity this side. Here also thumb is going upward. Fleming's left hand rule. So which direction? This is the along y direction. Basic is there. Basic. Is it? Can you see here? Is it? Great. Now students, next one we are going to see this question. Now before we have learned the application, now we have to just do some calculation. Basic is same. See, an infinitely long conductor carries a current of 5 ampere as shown. Now here what is happening? Current of 5 ampere is flowing here. An electron is moving with a speed of 10 to the power 5 meter per second parallel to the conductor. The perpendicular distance between the electron and the conductor is 20 centimeter at an instant. Calculate the magnitude of force experienced by the electron at that instant. Is it? So see here now. First we will calculate here the formula is what? F equal to QV cross B. So first we will calculate here the magnetic field. What is the magnetic field formula? Due to the infinite wire, it is given by, remember that here students please, mu naught I by 2 pi d, due to infinite wire, na? And this is the perpendicular distance d. Is it? So what this will come here? Kindly see here. This mu naught value I will write here 4 pi into 10 to the power minus 7 into current. How much is given here? You can see very well. The current is given here 5. Is it? By here 2 pi into d. Distance what is given here? Perpendicular distance. It is given here the 20 centimeter. Is it? So what we can write here? See, 20 into 10 to the power minus 2. Okay. So here what we can write here students, kindly see here. Now, so this is 2 pi, this is 4 pi. 2 will come after that, kindly see, 5 4 is 20. So 2 by 4 means it will become here 1 by 2. Is it? And 10 to the power what will come? Minus 2 will go upward. So 10 to the power minus 5 Tesla. Is it? This is the magnetic field. In which direction? See, all the fingers along the current, palm towards the observation pointer. Then thumb is coming which side? Outside here. Is it? So what is happening that here? This magnetic field is outside B. Is it? Now after that students, we have to calculate here the force. But remember that here, which particle is there? Electron is there. Electron. Is it? So we can write here the charge Q is what? Minus E. Electron is there. Okay. So velocity what is given here? 10 to the power 5 meter per second. So students, remember that here, if I use here the formula, no, just I will use here the magnitude, no, because I cap, J cap, K cap not there. So no need to worry about that. What we can write here? QVB sin theta. So what is Q? Just write here E magnitude, no need to write minus E. So EVB into sin. What is theta? Theta is the angle between velocity and the magnetic field. Velocity which side? This side. Magnetic field outside, velocity along x direction. Magnetic field along positive z direction. How much angle? You can see here. 90-degree angle. Is it? So sin 90 is there. We have to just use here EVB. No need to use minus sign. Okay. Don't use minus E here, no, because only magnitude is there. When you are using the vector, that time, okay, if you are interested means that time you use minus E into V cross B and all, okay? But here no need, just we have to just use this Fm equal to EVB. Is it? This thing is there. After that, we'll just put here the values and all that here, okay? So just let me write here what is given. See, this magnetic force, what is coming here? EVB, value of E how much? 1.6 into 10 to the power minus 19. Velocity, you remember, the velocity is, students, 10 to the power 5. Okay, so I will write here 10 to the power 5 into magnetic field, what we have got here, kindly see, half into 10 to the power minus 5. Okay, so see, half into 10 to the power minus 5. Okay, so I can write here, see here, 1.6 by 2, it will come here 0.8 into 10 to the power. See, students, this plus 5 minus 5 will cancel, so 0.8 into 10 to the power minus 19. Is it? To get the answer in a required form, you can multiply and divide by 10, because when we are dealing with the power of 10, we have to be very, very careful. So what will happen right here? Just 0.8 into 10, it will become here 8. 10 power minus 19, this 10 power 1 will go up. So 8 into 10 to the power minus 20. Can you see here? Is it? So what is the answer here, students? See, 8 into 10 power minus 20 Newton is here. Option D is the answer. If in case you are interested in a direction of force, now the negative charge particle is important. What is the direction of the force? Just for the basic purpose, see, this is the velocity, this is the magnetic field. Direction of the force for the negative charge particle, what we can tell? Minus of V cross B. V cross B is going in which direction? See, this is V, this is B. So V cross B, this is V, this is B, first vector to the second vector. V cross B is downward. Is it? That means for positive charge particle, downward. But here which particle? Negative charge particle. That means direction of the force is where? Upward. This will be the direction of force. Okay? Direction of force. Or you can use Fleming's left hand rule also. See here please. Now magnetic field is which side? Magnetic field is outside. Magnetic field is outside. This is the velocity. For positive charge particle, thumb is going downward. But for the negative charge particle, thumb will go upward. Is it? So kindly see here. So students, I hope so. This video of magnetic force acting on the charge particle and so many questions we have solved is very, very clear to you. Keep studying, keep going.